Here we are with our second practice for the Unit 4, Topic 2, Assessment Number 3. Okay, it should feel very familiar to the first one. I just went through and changed what each problem was about, the scenarios. So this time, Ms. Higgins is doing an experiment. She's going to take a bucket of water, freeze it, and then reheat it to its original temperature. All right, X is going to be time in minutes, Y is temperature Celsius. The fact that we're using temperature Celsius means that when it hits 0, that is actually when it freezes. We're going to decrease it even beyond that, though. You can see in the table, the temperature does go below the 0. Okay, it does go into the negatives. Just like the last one I gave you, there is not enough information in the table to tell, even if you assumed this was quadratic, you cannot tell where the vertex occurs. So let's go through and look at our differences. This goes down 13, down 11, down 9, down 7, down 5, and down 3. So I do see a linear pattern in my first differences. My second differences are positive 2. So I definitely know it is quadratic, but I can't tell where the vertex is. I don't have two x-intercepts to try to write directly to factored form. So I'm going to go through that long process again of solving for b to find our standard form. Okay, and standard form is ax squared plus bx plus c. The a is half of the second difference, so half of 2 is 1, so 1 for a. The c is the y-intercept, so that's the 40, that's the c. I'm not going to know what b is, and I'm going to have to choose a point to substitute in here for x and y. Now, just because I like the numbers, I'm going to go ahead and choose the point 3, 7. So everywhere there's a y, I'll put a 7. X, I'll substitute a 3. So 7 is equal to 1 times 3 squared. That means 1 times 9, or 9, plus 3b plus 40. 7 is equal to 9 plus 40 is 49 plus 3b. Subtract 49 on both sides. I'm at negative 42. Divide both sides by 3, so b is negative 14. So my standard form here is y equals 1x squared minus 14x plus 40. I am not expecting you to solve for that. I'm hoping that you will use quad reg as you do it. All right, our vertex and factored forms will come from the standard. So y equals x squared minus 14x plus 40. All right, first step in aiming towards vertex form, break your b in half. So half of negative 14 is negative 7. Square that is 49. So I'm wanting 49 out here. I don't have 49, I have 40. So let me add 9. But in order to do that, I also have to subtract 9. So I can rewrite as x squared minus 14x plus 49, right? That's my perfect square trinomial. And later I have a minus 9. Since I made that a perfect square, I know I can factor it as a binomial x minus 7 squared, and then minus 9. So there's my vertex form. And to go from standard to factored, I first will look for a GCF, but there is not one. So a times c, 1 times 40 is 40. That's the product I want. It's positive, so these signs will be the same, and they'll both match this middle sum of negative 14. So both negatives. So factors of 40 that add up to 14 are 4 and 10. So factored form is simply x minus 4 times x minus 10. Again, the grid says to graph only if you want to, and I certainly do not want to. All right, so what are the coordinates of the vertex, and what does it tell me about the water? So the vertex was at the point 7, -9. So coordinates of the vertex, 7, -9. And what it tells me about the water is the water reaches its minimum or lowest temperature, okay, which was -9 degrees Celsius, at 7, now were these minutes? Minutes. At 7 minutes. Which form was best for answering that? Of course, vertex form. What are the values of the x-intercepts, and what do they mean? Well, they were 4 and 10. We got that from factored form, x minus 4 and x minus 10. What do they mean in this context? That means the water/ice, the water was exactly 0 degrees Celsius twice, at 4 seconds, then again at 10 seconds. Minutes, sorry, we're in minutes here. Let me fix. So 4 minutes, then again at 10 minutes. And question 5 is going to ask, yeah, which form did we use to answer that, or was best for using it, and that would be factored. So what is the equation for the line of symmetry, and what does it tell you about the water? Well, because my vertex was at 7, -9, that x equals 7 would be my line of symmetry. What does, and make sure it's an equation, what does it tell you about the water? Okay, well, it tells us that the water reached its minimum, or it stopped decreasing after 7 minutes. At this point, it starts increasing. One thing you could say about your axis of symmetry is it's the point where you stop going one direction and start going the other. You could also point out that 7 minutes is the halfway point of the experiment. And then lastly, how long did the entire experiment take, and how do you know? Well, again, if the 7 minutes was the halfway point, then the whole thing took 14 minutes. Using my line of symmetry, I know the water decreased in temperature for 7 minutes. Therefore, it will take another 7 minutes to return to original temperature. And we're done.